Okay, so starting this problem off with identifying the equation needed, part A is asking for the magnitude of the magnetic field at some distance from the center of a loop. So since we're given magnetic field, or since we're trying to solve for magnetic field and we know it's from a distance of a loop, we're going to use the magnetic field of a loop equation to solve this problem. So after we get our equation, we see that we have variables. So now all we need is to plug in the values for these variables in order to answer and complete this question. So mu naught over 4 pi is actually a constant, so we have that. But honestly, we have all of the variables in this equation because they're actually given to us in our problem. So all we need to do is pick out the values of the variables from our question, plug them into the equation, and solve it. That's it. Now in part B, we're going to do the exact same thing. They ask us for the magnitude of the magnetic field at the same location. The only thing that is different is that instead of being one loop of wire, it's actually going to be 100 loops of wire because we're using a coil now. So the only thing that actually changes is that we are only going to multiply, we're going to use the magnetic field that we found in part A and just multiply it by the number of coils, by the number of loops that we have. So we have our equation, so let's find the number of loops from our question, plug it in, so we just times by 100, and then we get the magnetic field for the 100 loops at the same location.